We created equipment in CableMatic and developed load list reports, one-line diagrams, and motor control schematics. Now let's place equipment boxes in a 3D model. First, set a retrieval code for motors. We now associate an AutoCAD block to each termination box. A default installation detail has also been preset. Select an equipment tag from the list and place it in the model. We will continue selecting and placing equipment. The installation details contain links to the bill of materials required for each installation. This will enable us to generate a complete material list. Let's use Cool Tools to identify the equipment. Select the boxes, then Show and Tag will add the equipment tags and descriptions. Now we will locate control stations near each motor. Set the retrieval code in the AutoCAD block. Select from the list and place the box in the model. We will complete our Raceway by routing conduits from the tray to the end devices. Select the Conduit and Dropout tab and set the retrieval code for power conduits. Next, select the conduit type. Selecting RGS conduit and unlocking the size will automatically set the size to the NEC fill requirements. We have automatic or manual conduit routing options. Let's auto route to the closest tray. We can also auto route to a selected tray. The closest tray would be the one below, but we will route to this one instead. Now let's auto route these last 4 and move on to the next step. To route cables, we will need to add the source. Set the retrieval code, select the appropriate motor control center, and place it in the model. We will add a field route raceway from the MCC, and we will be ready to route cables. Cable routing is available in Cool Tools. Using the equipment in this list, we can identify the connected cables, populate the cable list, and select route. You can see and verify the routes by selecting Show. In addition to viewing cable routes in AutoCAD, we can get additional reports from CableMatic. Let's open it and select the cable report. We will get a list of all cables originating in MCC2 and generate a cable schedule for it. This standard cable schedule includes the raceways and links for cables that have been routed. This length will flow back to CableMatic, where voltage drop will be calculated. Cable schedule reports are also available in Excel format and can be customized. Now let's return to AutoCAD. I'm going to erase everything in this drawing. We will retrieve the equipment from the database. I've added several motors and control stations as well as light fixtures. Next, we will display the attached AutoCAD blocks. Associating an installation detail to each item allows us now to generate several useful reports. The first report shows how many times each block is used in this drawing. The second report lists the installation details and the quantity required for each. The third report shows a complete bill of material, including manufacturer catalog number and quantity. In addition to the cable schedule, CableMatic offers additional useful reports. Let's start with a tray fill report. We'll select power trays and have the report include a list of cables. Assign a name for the report and create. The report shows the cables in each segment, the fill percentage, and the NEC fill rule used for the calculation. Next, we'll generate a conduit report. We'll call this one Conduit Schedule. The report shows the conduit number, size, the cables contained, and the fill percentage. Material reports are also available. In a cable report, for each cable type, we will find the manufacturer and catalog number, the total length, and the number of cable runs. These reports are customizable and are available in Excel format.